So this is the review exercise 1 video, things that we were stuck on this week. So question 4 is the first thing on my list. And I would say this is the sort of thing that if you're not happy with this one, then you definitely need to be going back and having a look again at the first couple of chapters. This is the sort of thing that you want to get very easy, very smooth. So first of all, we get 125 to the power of 4 over 3. Well, the 3 in the denominator in the power there means the cube root, so the cube root of 125, and then to the power of 4. So cube root of 125 is 5, and then to the power of 4, so 5 to the power of 4. Now this is a non-calculator paper, so how we're going to work that one out, I think probably the easiest way to do it without a calculator is to think of it as something like 5 squared times 5 squared, so 25 times 25, and then probably some sort of column method to do that, unless you happen to know what 25 squared is off the top of your head. Again, though, this is well, not again, but this is not an exam paper question, so perhaps they're not going to get that mean in the exam, but there's no reason they couldn't, so probably the easiest way to do it like that. Part B, we've got 24 x squared divided by 18, x to the power of 4/3. Oops, that's a 3 there we go. Well, 24 divided by 18, let's have a look what we can get. 3 can go into both of those, so 8 over 6, and I could have done a bit better than that, but never mind. And then with the x's, we can do a take away with the powers, so 2 take away 4/3. 8 over 6 is 4 over 3. Of course, 6 goes into 24 and 18, so I could have got there a bit quicker. Now, this 4/3 is 1 and a third, isn't it? So 2 take away 4/3 is going to be 2/3. 2 take away 1 and a third. Is there anything better we can do than that? I think that's probably as nice as we can leave that one. So that's question 4. Question 11, I think, is the next one on my list. Let me just check. Yeah, question 11. Okay, question 11. So we have the first part is asking us to complete the square there, and then the second part is saying show that the roots of this are these values. So 11 part A is just a completing the square question. Now there's different methods to doing this. The one that most people prefer is the one that looks like this. If you really dislike this method, then I can show you a slightly different method, but this is one that most people like. So we're using the identity. Let me just write that again. X squared plus bx is exactly the same thing as x plus b over 2, all squared, take away b over 2, all squared. While we're talking about this, this is the tricky bit that people often get this bit here wrong. So you do b over 2, then you square it, then you times by minus 1. So as a quick check, this is always a minus sign after the brackets, because you square something, and that's going to be positive, then you times it by minus 1, so you always get a minus sign after the brackets. So using that with b equals minus 8 means that we get x squared minus 8x equals x plus, minus 8 over 2 is minus 4, all squared, take away b over 2, so this b over 2 here, minus 4, then square it, so that's 16, then times it by minus 1, so that's minus 16. And if you're not sure, then just expand this out again in your head. So x times x is x squared, x times minus 4, x times minus 4, so that's minus 8x, then minus 4 times minus 4 is plus 16, then take away the 16, so this right-hand side equals this left-hand side. And then if we go back to the question has x squared minus 8x minus 29, so x squared minus 8x minus 29, equals x minus 4, all squared, and then minus this 16 and minus this 29 is going to be minus 45, I hope, if I can add up at least. Yeah, that looks right to me. Okay. Hence or otherwise show that the roots of this equation are c plus or minus d root 5, where c and d are integers. Oh, by the way, if you on part A this is our final answer. So if you were in the exam, you probably want to say that A is -4 and B is -45 and put a ring round all of that. So A equals -4, B equals -45, and that there, all of that is your final answer. So part B. Let's just move all this out of the way. So what we've got is the equation. Now, there's a couple of ways we can do this. We've got here a quadratic. You know you've got three methods of solving quadratics. You know that factorising is not going to work because they tell you that the answer has a surd in it. So you could go for the formula, or you could go for the completing square method. Now, you wouldn't usually use the completing square method, except that we've already completed the square. So we've got that x minus 4 all squared minus 45 equals 0. And that is the same as the equation that they've given us. So from here, we can just use the balance method now. Once we've got the completed square form, we can use the balance method to finish this off. So x minus 4 all squared equals 45. Square root both sides, we get x minus 4 equals plus or minus 45, plus or minus square root of 45. And then x equals 4 plus or minus square root 45. And 45, of course, is 9 times 5. So it's 4 plus or minus square root of 9 times 5, so square root of 9 times the square root of 5 will give us that answer there. Just a little bit of simplifying surds in this last line here. So C equals 4 and D equals 3. That's question 11. Next on the list is question 13. Let's have a look. Question 13. Given that this equation where k is a positive constant has equal roots, find the value of k. Okay. So there's a lot of questions like this, and they often tend to stick a k in as the unknown letter. There's no reason it needs to be a k, but it might be a little sort of hint for us when we're in an exam that they often like to use the letter k in questions that are aimed at testing whether or not we know about the discriminant. So in the exam I'd write, consider the discriminant, or consider b squared minus 4ac, where we have a equals k, that's the coefficient of x squared, b equals 12, that's the coefficient of x, and c equals k, which is the constant term at the end of the equation. So we're going to have a look at this. So 12 squared minus 4 times k squared. And the question says we have equal roots, so that means that the discriminant equals 0. Now I know some people remember this as equal roots means that b squared equals 4ac, and you know, and for no real roots or two real roots, we have the equivalent of that with some inequality signs thrown in. I'd advise you really, I think the discriminant is a slightly better way of thinking about it. It doesn't matter too much if you really like those b squared equals 4ac and b squared is greater than 4ac and b squared less than 4ac, then that's fair enough. The main reason though I'd advise the discriminant is because in the exam it makes it easier to describe what you're doing. So consider the discriminant, and then it's equal to 0. So, and if you're in an exam, you'd need to put in a note here to say our discriminant is this, and we're putting it equal to 0 because the question tells us we have two real two equal roots. Might be called repeating roots, of course. So that is 144 minus 4k squared equals 0. Now this is a quadratic equation. You can pull out all your bag of quadratic tricks if you like, but this is a quadratic equation which we can solve just by the balance method. So 144 equals 4k squared. Divide by 4 on both sides, and we're going to get 144 divided by 4. So I think I'm being very slow today, so that's 25 plus 10 plus 1, so 36 equals k squared, so k equals plus or minus 6. There we go. Okay, that I think is the end of question 13. So this is question 14 next. So the first part here is another complete the square part. It's exactly the same as the part A of question 11. So if you're stuck on part A of question 14, then scan the video back and have a look at question 11 and doing exactly the same thing. Then we're showing that an equation has no real roots. Now, there's a slightly different thing here. One is it says hence. Now, it doesn't say hence or otherwise, so it means that it wants you to do it by using part A. In an exam, if you decided to use the discriminant, again, exactly the same method as I used in question 11, then you could use the discriminant to show that the discriminant is negative and it has, so therefore the equation has no real roots. But it doesn't say hence or otherwise, it says hence, so really we should do this now by using the answer to part A, which I'm just going to cheat for a second and find this in the back of the book. Let's have a look, here we go, so review exercise 1. So from part A we have x plus 5 all squared plus 11. So, hang on a second, x plus 5 all squared plus 11. And that is the same as x squared plus 10x plus 36. So our equation in part B can be turned into this equation here. And if we just try and solve this, we get x plus 5 all squared equals minus 11. And at this point, if we try and square root, we're trying to square root a negative number, so we get no real roots there. Could use the discriminant, but that's, I think, the method they're wanting. Now then, part B then. So this equation they give us has equal roots, find the value of k, and for this value of k, sketch the graph showing the coordinates at any points where the graph meets the coordinate axes. So, unusually, it seems like a pretty separate question. Usually in a question, particularly an exam question, you'd look for the link between part A and B and part C. Obviously we've got x squared plus 10x in both cases, but not much else really. Oh, I suppose what it is that the x squared plus 10x, when we complete the square, we're going to get an x plus 5 all squared. But there's not a great deal really, so no, I'm not going to use anything from part A and B. I think the way I'm going to do it is like this. We'll just say consider the discriminant. Oops, excuse me, that's me leaning on the iPad. So we'll consider the discriminant, which is b squared minus 4ac, and in this case a is 1, b is 10, c is k. So that is 100, which is 10 squared, minus 4 times 1 times k, and for equal roots we want that to be 0, so the discriminant is 0, so 4k equals 100, so k equals 25, and sorry, yeah, k equals 25, that's right, isn't it? Yeah, there we go. For this value of k, sketch the graph of this thing showing the coordinates at any points at which the graph meets the coordinate axes. So, if we've got real roots, we know we're going to get a graph which just touches the x-axis, and it doesn't actually cross the x-axis, it's just the turning point here is exactly where the x-axis is. And sorry, I keep pausing here because I'm trying to think how part A and part B are helping us with part C and part D, but they don't seem to be a great deal. So we just need to know where this crosses the axis. So this is y equals x squared plus 10x plus 25, which is y equals x plus 5 all squared if we factorise from here to here. So this point here, I've actually sketched this wrong. When we hit the y-axis, x equals 0. When we hit the x-axis, y equals 0. If we put y equals to 0 in this, then we get x equals minus 5 out. So x equals minus 5 is where it crosses the where it touches the x-axis. Sorry. And where does it cross the y-axis? Well, it crosses the y-axis when x equals 0, which is at 25, and we can get that from substituting x equals 0 into this one or into this one. So our sketch is actually going to look like this. Obviously it'll be easier for you to draw it not trying to do it on an iPad, but that is 0, 25, and this is minus 5, 0. Obviously with labelled axes and everything else. Okay, that's question 14. Question 15 is next. Let's have a look. The first part, find the values of the constants a and b. Again, it asks us to complete the square. So we did that in question 11, part A. So if you're not sure how to do part A, then go back and watch question 11. It's exactly the same method and nothing different there. Then sketch the graph indicating clearly the coordinates of any intersections with the coordinate axes. Well, that's the same as question 14, part D. We'll do it again though, just in case there's any slight differences. Let's read part C first of all. Find the value of the discriminant of x squared plus 2x plus 3. Explain how the sign of the discriminant relates to your sketch in part B. So again, we'll look at the sketch in part B. We'll see how many solutions there are. If there's no solutions, the discriminant is going to be negative. If there are two solutions, the discriminant is going to be positive. And if there's one solution or equal solutions, then the discriminant is going to be equal to 0. And the number of solutions is the same as how many times the graph crosses the axes. So part A and part B, we get, let's write the answers down because we might need them for part C and part D. X plus 1 all squared plus 2 is the completed square form, and that leaves us with a graph that looks something like this. It's crosses the y-axis at 3, and it has no x-axis crossing points. We can tell it has no x-axis crossing points because we try and solve y equals x plus 1 all squared plus 2. If we put y equal to 0 to try and find where it crosses the x-axis, then we're trying to solve this equation, and that's minus 2 equals x plus 1 all squared, and to solve that we'd need to square root a negative number, which we can't do, so we've got no x-axis crossing points. If we work out the discriminant of the quadratic, that's a equals 1, b equals 2, c equals 3. So b squared is 4 minus 4 times 1 times 3, so that's 4, take away 12, that's negative, as we said. The equation x squared plus kx plus 3 equals 0, where k is a constant, has no real roots. Find the set of possible values of k, giving it answer in surd form. So moving on to this part then, part D. Again, I can't see the link here really between part A, B, and C and part D. We have the same x squared term and the same constant term, but that's not going to help us a great deal. So let's just go straight into it. A equals 1, b equals k, and c equals 3 from the equation. So the discriminant is b squared, which is k squared, minus 4 times a times c, k squared minus 12. And if that has no real roots, then k squared minus 12 is negative, is less than 0. Now this thing here is a quadratic inequality. So what we need to do is draw a graph. K squared minus 12 is less than 0. So let's draw y equals k squared minus 12. The solution of the equation k squared minus 12 equals 0 is k equals plus or minus square root of 12, which is plus or minus 2 root 3. So our graph is going to look something like this. So y equals k squared minus 12 is less than 0 for this part of the graph. So what we're looking for is the solution 2 root 3 is less than k is minus 2 root 3 is less than k is less than 2 root 3. And remember, with a quadratic inequality you always have to draw a graph, because until you draw a graph it's difficult to know whether you want these parts of the graph that I've done in blue or this part of the graph which I've done in red. So the key is spot that it's a quadratic inequality and always draw the graph. Now that is a very common question. As you've probably seen, it comes up a few times in the mixed exercise, so make sure you're happy with that sort of question before you hit the test or the exam. Next one on my list is question 21. So we need to solve a set of simultaneous equations and then hence or otherwise find the set of values for x for which 2x squared minus 3x minus 16 is greater than 5 minus 2x. Well then, part A, we're going to notice here that we've got one linear equation and one non-linear equation. So we've got to go for the substitution method. Now if you're not used to that already, substitution method at A level is much more common than anything else. So I'm going to take the first equation and rearrange it like that. Now just looking ahead to part B, I think it might also help to rearrange the second equation so that y is on its own. Usually I wouldn't bother doing that. I know some people prefer to get one variable on its own in both equations and then sort of put the right hand sides equal to each other. Personally, I would normally take this first equation here and substitute 5 minus 2x into the second equation. But this time, because of what I see in the second part, I'm going to write it like this. And I'm going to call that equation number 2. So I'm going to sub from 1 into 2, which is going to give me 5 minus 2x equals 2x squared minus 3x minus 16, which is almost exactly what we've got in part B, except there's an inequality sign there as well. So from here then, let's have a look. We're just solving a quadratic, aren't we? So 0 equals 2x squared plus 2x on both sides minus 5 on both sides. I feel like this might be factorisable, so there might be a bit of a mess going on here, but something like a 7 and a 3 should do it, shouldn't they? So I just feel like if I put a 3 in here and a 7 in here, how does that work? Let's have a look. 2x squared plus 6x minus 7x, there we go, minus 21. So x equals 7 over 2, or x equals minus 3. So those are my two x values, and then if I substitute those back in for my y values into equation 1, we're going to get y plus 2x equals 5. So I'm going to get a bit sloppy again with the way I'm writing this, but just y plus 7 equals 5, so y equals minus 2. That's from just substituting this value into the first equation. Substituting this value into the first equation, we get y minus 6 equals 5, so y equals 11. Okay, obviously in the exam you wouldn't be able to say I'm substituting this in, so you'd have to write that down. So those are my two pairs of solutions there. Now, hence or otherwise, find the set of values of x for which we have this inequality. Now, for part B, there are two ways forward here, really. One is to notice that's a quadratic inequality, and the first, most important thing is when you have a quadratic inequality, you must draw a graph. Now, for this one, we can see that that is a quadratic inequality which is linked to the equations that we've had in part A. So we can use that to help us out. We don't need a particularly wonderful graph here, but instead of drawing the usual graph, which would be to take the quadratic, get a 0 on one side of the inequality sign, put everything over the other side of the inequality sign, and then sketch a quadratic graph, which we could do here, that would work perfectly well. But what I'm going to do instead is I'm going to sketch y equals 2x squared minus 3x minus y equals 16. So I'm going to sketch that first, I'm going to sketch 2x squared minus 3x minus 16 equals y. Okay, so I'm going to use equations 1 and 2 from up here. I'm going to sketch these two things. Now, this one I'll sketch first. I don't need to know much about it. All I need to know, really, is that it's a quadratic. So when I sketch it, what's it going to look like? It's going to look like that. I mean, that could be an absolutely terrible sketch. Maybe the x-axis and y-axis crossing points are completely in the wrong place. The only thing that's important for this question, though, is that it is a u-shaped parabola. We know it's a u-shaped parabola because the coefficient of the x squared term is a positive number. It's a 2 there. And then for this line, for this line here, it's got a y-axis crossing point of 3 and a gradient of minus 2. So I think let's have a look. Let's just try and make a roughly accurate sketch. It's not very accurate, but that doesn't matter. The important point is where the crossing points are, and the crossing points are the things that we found in part A. So what we want is the values where the quadratic is higher than the line. If we look at the part B question, it says 2x squared minus 3x minus 16 is greater than 5 minus 2x. So we want the quadratic higher than the line. So where's the quadratic higher than the line? That is this part here and this part here. So we want the x value, so we want x is less than 7 over 2 and x is less than minus 3, because this x value here is going to be minus 3. This x value here is going to be 7 over 2, or 3.5. So x is less than minus 3 and x is greater than 7 over 2. That's going to be our solution there to question 21. Question 22 is the next one on my list. So this equation, x squared plus kx plus k plus 3 equals 0, where k is a constant, has different real roots. Now, this sort of question comes up a lot. In fact, we've already seen very similar things in questions sort of 14 and 15. What we get is this. We have, first of all, the idea of roots is asking us that it has different roots, different real roots. I.e., another way of saying that is two real roots or distinct roots or something like that. But what we're looking for is the discriminant being positive. And in this case, A equals 1, B equals k, and C equals k plus 3. So let's just work this out. K squared minus 4 times 1 times k plus 3. That's our discriminant. We want that to be positive. So k squared minus 4k plus 12 is greater than 0. Oh, hang on a minute, sorry. That's a minus 12, isn't it? That's a minus sign there and a plus sign there. So that is part A. Okay, maybe a few more details in there if this is an exam. Writing in here something like, consider the discriminant b squared minus 4ac with this gives, and we might want to explain that it has to be greater than 0 because there are two real roots. Find the set of possible values of k. So what part B says is just solve this inequality. Now that, okay, it's k's not x's, but we can now put aside part A really for part B and just say, here's an inequality, solve it. To solve that inequality, we've got to deal with it like any other quadratic inequality, and we've got to sketch the graph of y equals k squared minus 4k minus 12. In order to sketch that, we need to know where it crosses the x-axis. If it was a graph sketching question, we probably want to know where it crosses the y-axis as well, but in this question, the important thing is where does it cross the x-axis? Where does it cross the x-axis? That's where y equals 0. So y 0 equals k squared minus 4k minus 12. That's where 0 equals, there's got to be something we can do to factorise this. Let's see, 6 and 2, and a minus 6 and a plus 2 I think will work. So that's where k equals 6 and where k equals minus 2. Can't say too many times to solve a quadratic inequality, draw a graph. That's what we've always got to do. So let's draw this graph. Crosses the x-axis at 6 and minus 2. It's a U-shaped parabola because the coefficient of the k squared term is 1, which is a positive number. We want to know where this quadratic is bigger than 0. That means that we want this part here and this part here. Okay? So that means we want k is less than 6. So keep doing this. K is less than minus 2 and k is greater than 6. Make sure you don't make the same mistake I just made. Making it again. Make sure you put the crossing points on your axis, minus 2 and 6. Okay? You don't know without drawing it if you want this curved part of the quadratic or these branches of the quadratic. Always draw it if you've got to solve a quadratic inequality. That was question 22. 22, I think. Is that right? Question 22. Yeah, question 22. Okay, so question 23 is just the same as question 22, but in one part here. So question 23. Oh, we'll switch to a blue pen since we're already there. So this thing has no real roots, so we consider the discriminant, which is where a equals 1, a equals k, b equals 3k. Oh, excuse me, there's a crying baby in the background. My wife's dealing with it at the moment, but I might be off in a second. So a equals k, b equals 3k, c equals 2, and we want to deal with b squared minus 4ac. b squared minus 4ac is 9k squared minus 4 times k times 2. So the discriminant is 9k squared minus 8k. And the condition they give us in the question is no real roots. So we need to consider the situation where 9k squared minus 8k is less than 0. So what values of k satisfy this inequality? That's a quadratic inequality. We're going to need to sketch a graph. K times 9k minus 8 is less than 0. Let's factorize it there. So because we're trying to sketch the graph of that, y equals that. The important detail is where it crosses the. In fact, in question 22, I said x-axis, didn't I? But in this case, it's not actually going to be an x-axis; it's going to be a k-axis, isn't it? So we've let y equal 0, which gives us k equals 0 and k equals 8/9. So when we sketch the graph, we're going to get this sort of situation with that being 8/9 and with that being 0. We want the part of the graph where that is less than 0. So we want this part of the graph. So what we want is 0 less than k less than, oh, that should be a 9 there, shouldn't it? 8/9. Always sketch a graph if it's a quadratic inequality. I think I might have mentioned that once or twice already. That's question 23. Question 24. Now, I think question 24 might be one of these where I say, have a look at the last couple of questions. I've just done question 22 and 23, so if you're coming in here at question 24, it's a very similar question, only we have p's instead of k's. So this equation, where p is a constant, has different real roots. So show that p squared minus 8p minus 20 is greater than 0. What we've got to do there is we've got to think about the discriminant, b squared minus 4ac. A in this case is 2p plus 5, that's the coefficient of x squared. B is just p, that's the coefficient of x. And c is 1, that's the constant term. If we work out b squared minus 4ac, we'll end up with p squared minus 8p minus 20. And the question tells us that this equation has different real roots. In other words, the discriminant is positive. So we work out the discriminant and we say that it's got to be greater than 0. It's exactly the same as question 22, part A. Part B, find the set of possible values of p. Well, that is just a case of solving p squared minus 8p minus 20 is greater than 0. That is a quadratic inequality. You must draw a graph of that quadratic. Look at where it crosses what would be the x-axis, but what in this case is the p-axis. And you need the part of the graph which is above the x-axis. Now, given that p equals minus 3, find the exact roots of this equation. Now, that's a slightly new thing, so let's have a go at that one. Well, if p is minus 3, 2 times minus 3 plus 5 times x squared, minus 3x plus 1 equals 0. So that is minus 6 plus 5 is minus x squared, minus 3x plus 1 equals 0. So any method you prefer from here, you could go straight for the formula. And I think that's what I'm going to do, because just looking at that 1 and that 3, I don't think we're going to get anything nice to factorise there. So we'd say x equals minus b plus or minus the square root of b squared minus 4ac over 2a, where a equals minus 1, b equals minus 3, c equals 1. So x equals 3 plus or minus the square root of 9 minus 4 times 1 times minus 1 over minus 2. So x equals 3 plus or minus root 13 over minus 2. Well, let's times the top and the bottom by minus 1, and we're going to get x equals minus 3 plus or minus, so minus or plus, so the same thing, root 13 over 2. And if you're on an exam, perhaps write that out as 2 separate minus root 13 over 2, just to make it clear that those are 2 different solutions there. So that is question 24. Last one then, question 25. First of all, factorise completely x cubed minus 4x. Now that completely is usually a warning here to not just do one stage of factorisation. So the obvious thing is take the x out the front, but there's a clue in the question that when you've done one bit of factorising, you've not quite finished. So you've got half the marks so far, but this x squared minus 4 we can do by a difference of 2 squares, x minus 2, x plus 2. Okay. Now if you look at the question, it is a cubic, so you're expecting 3 factors there. Okay. Right, I've, as you might have guessed, just had to go and deal with a crying baby. So I can't remember where I left off, but we're looking at part B now. So, sketch the curve with this equation. Well, if we look at that equation, it is a cubic. Cubics we know look like this, or look like this, and occasionally they look like this, or like this. These ones here, obviously, are the ones where we have repeated roots. In this case, we have 3 separate roots. We've got y equals x, x minus 2, x plus 2. We want to know where it crosses the x-axis. That is when y equals 0. No, yes, when y equals 0. So that is when x equals 0, or when x equals 2, or when x equals minus 2. Okay, so those are the points where we cross the x-axis. We cross the y-axis again at 0. The easiest way to see that is probably to well, we can use this form of the equation. Crosses the y-axis when x equals 0. When x equals 0, that's 0 times this lot here, so y equals 0 as well. So we have, if you look at the part A of the question, we get x cubed minus 4x is the same as this factorised version. And we need the leading coefficient, that is the coefficient of the x cubed term, to know which shape it's going to be. This shape is the one we're going to be looking at because it's a positive coefficient of the x cubed term. So we have crossing points at 2, minus 2 and 0, so it's got to look something like this. I've tried to make it so that this lump here and this lump here are the same size. I'm not sure if I've achieved that, but minus 2 and 2. They're not always the same size, by the way, because but in this case they are, because of where we're hitting the x-axis at 2 and minus 2. We could have a cubic that does something like this. Oh dear, that's a terrible drawing, but the point is it depends. The thing is not always symmetrical about the x-axis, if you see what I mean. Okay, part C. On a separate diagram, sketch the curve with this equation. Now, this is a really good example of where you need to have a look at the earlier parts of the question for clues. By the time we get to a part C or D, usually part A and B are going to help us out. We could try and solve this question by as though we'd never seen part A and B, in which case what we'd probably do is we'd take that equation and maybe we'd think about sort of expanding it out and trying to work out what the cubic is and that sort of thing. Now, that's not really going to help us. What will help us, though, is if we just write those equations next to each other. So part A was y equals, oh, what's that? Oh, there we go. Sorry, I haven't got my pen selected. Y equals x cubed minus 4x. And the equation from part C is x minus 1 cubed minus 4 lots of x minus 1. In fact, let me write that a bit more usefully. X cubed minus 4 lots of x. And hopefully we can see that this x here has been replaced by an x minus 1 here. This x here has been replaced by an x minus 1 here, and everything else is the same. So if this first equation, we, instead of calling it y, called it f of x, then this second equation is f of x minus 1. Instead of putting an x into the function, we put an x minus 1 into the function. And we know that to go from f of x to f of x minus 1, that's a slide to the right, one space from our transformations of graphs stuff. So the clue here on the review exercise is that it's on question 25 is that it's a green question, which is the colour which goes with the green chapter, and that green chapter is, I can't remember which number it is, let's have a look, chapter 4, which is the graph sketching chapter. Obviously on an exam you wouldn't have that clue, but we've got that clue here, so maybe that helped us out. So all we're going to do is take the graph that we've already seen. Oh dear, this is terrible drawing on my part, but never mind. And it's so this graph has been slid to the right one space. So that means that's going to be minus 1. That's going to be a 1 there, the point where it hits the x-axis again, and that's going to be a 3 there. So that means this peak of the graph is going to be on the axis, and this here, this peak of the graph is going to be at 2. And it doesn't ask us for the y-coordinates of those points, it just asks us for the points where the curve crosses the x-axis, which we've already shown. So there is our answer. And that should be all the questions.